So far, we've learned that economists love to study the relationship between variables, and they use graphs, math, data, and words to convey and support their own predictions on how people behave. The next step is to delve a little deeper and start thinking like an economist. So if you want to start thinking like an economist, you should really start reading and listening to what economists are writing and what they're saying. So here are some popular economics websites and blogs. They're also listed on the Learn website. One of my favorite things to do is download the NPR Planet Money podcasts and Freakonomic podcasts and listen to them on my drive into work. So I suggest you do that. And you can also check out some data. So peruse some of these sites. They're really neat. One of my favorites is Gapminder. So see if anything strikes you as interesting. Links to these websites are also on Learn. And you'll learn that economics is a very broad discipline. Here at UNM, we have several interdisciplinary programs related to economics, including the RWJF Center for Health Policy and the Science Impact Lab for Policy and Economics, amongst many others. We also have a chapter of ODE, Omicron Delta Epsilon, here at UNM, which is the International Honor Society in the field of econ. So after meeting several requirements as an undergrad, you can apply to be a part of ODE. All right, moving on to the lecture. The outline for thinking like an economist is as follows. We'll talk about positive versus normative analysis, the scientific method in economics, and I'll introduce you to economic models. By the end of the lecture, you ought to be able to differentiate between positive and normative analysis, outline the steps of the scientific method, define an economic model and explain its importance to economic analysis, discuss the role of assumptions in economic models, and differentiate between exogenous and endogenous variables. So if you recall, my favorite definition of economics is the following. It's a social science that studies the social problem of choice from a scientific viewpoint. In other words, economics involves the formulation of theories and the examination of data to test the validity of theories. One way to think about the economist is to think of him or her as having two roles. The first one is being a scientist, in which the economist tries to explain the world around him or her. So as scientists, economists make positive statements, which attempt to describe the world as it is. You can also think of economists as being policy advisors, in the sense that they try to improve the world around them. So as policy advisors, economists make normative statements, which attempt to prescribe how the world should or ought to be. Now you should know, although economists play these two roles, scientists and policy advisors, what we really want to do is stick to positive analysis. Let's go through some examples. Normative statements. The government ought to ban smoking in public places. The level of tax on gasoline is unfair. Versus positive statements. Remember, those things that describe the world as it is. The city of Knoxville's ban on smoking in public places has increased restaurant sales revenues. The increase in the gas tax reduced gasoline consumption. The easiest way to remember this is that positive statements can be confirmed or refuted with data, and normative statements cannot. Normative statements are just opinions. So again, remember, economics is really about being a scientist and conducting positive analysis. Now you try identifying positive versus normative statements. Which of these statements are positive and which are normative? How can you tell the difference? I suggest that you pause the video and try to write down the answers before moving on. The first statement reads, prices rise when the government increases the quantity of money. So we need to ask ourselves, is that something that can be confirmed or refuted with data, or is that an opinion? And the answer is that it can be confirmed or refuted with data. So it's a positive statement, scientific. It describes a relationship. B, the government should print less money. That's clearly an opinion, so that's normative. It's a value judgment. It can't be confirmed or refuted. C, a tax cut is needed to stimulate the economy. Again, this is an opinion. It's a value judgment. And finally, an increase in the price of burritos will cause an increase in consumer demand for music downloads. So I know that this statement's a little weird, but it's still a positive statement because it describes a relationship. It can be confirmed or refuted with data, even if it sounds silly, and it doesn't sound true at all. So you were probably surprised to learn that economics is a social science, emphasis on science. This means that economists approach questions with a scientist's subjectivity. Economists think analytically and objectively. They develop theories, collect data, and analyze the data to evaluate these theories. In other words, economists make use of the scientific method just like scientists from the hard sciences do. A scientific method is just a method or procedure consisting in systematic observation, measurement, and experiment, and the formulation, testing, and modification of hypotheses. So here's a graph of the scientific method, and sometimes if you Google scientific method, graphs will look different. There's different steps, maybe in different orders. This one makes the most sense to me. So let's just go through it very, very briefly. So as an economist, you want to select a scientific question that interests you and do some background research, do a little lit review. So for example, I noticed that students who come to my 105 class regularly have higher exam scores. You have a question, now you want to state your theory or hypothesis. So for example, if students come to class more, they will earn a higher exam average. That's my hypothesis. So the next step is to transform that hypothesis into a mathematical model. So here I've written down an equation, and it's okay if you don't understand it yet, but keep it in the back of your mind as we move forward in the course. But I'm going to say in math terms, using symbols and using equations, that someone's exam average depends on or is a function of how many times they've come to class. And I'm going to say that beta 1, beta sub 1, looks like a B, is greater than 0. And all that means is that if the number of attendances goes up, that person's exam average goes up. And note that models don't necessarily have to be mathematical. They can certainly be a graph, or we can just say things verbally. But since this portion of the course has to do with math, we're going to stick with the mathematical model. So I've specified my mathematical model. I think that the number of attendances increases, that the exam average goes up. So now I'm going to collect data. I'm going to see if this is correct. So maybe for the next few semesters, I'll use iClickers and I'll track attendance. And I'll use the data on attendance and the data on exam averages to see if my mathematical model holds true, if my hypothesis is true. So I'll perform some data analysis, some regression analysis to estimate that beta 1 to see if it's greater than 0. And then I'll reject or accept my hypothesis or my prediction that higher attendance leads to a higher exam average. And if I accept my hypothesis, that's great. I'll report those results. If I reject my hypothesis, I'll have to start over again. Maybe rethink the assumptions, rethink the model. So we know that economists like to approach these questions by using the scientific method, thinking like a scientist. And at the heart of this is specifying that economic model. But what exactly is an economic model? An economic model is a simplified version of a more complex reality. In other words, irrelevant details are totally stripped away. And economic models are used to show relationships between variables, explain economy's behavior, and devise policies to improve economic performance. And you're familiar with models. A roadmap is a model. A model of human anatomy from high school biology class. and a model airplane. Often, we use the assumption of ceteris paribus, which just means other things equal. In other words, if we want to explain how a change in one variable affects another variable, we have got to assume that all other variables are held constant. If everything is changing simultaneously, then there's no way that we can sparse out what affected what. So you'll come across this phrase later on. And then finally, when we think about economic models, we have to differentiate between endogenous variables and exogenous variables. So endogenous variables are those that are originating from within the model. So they're the variables that are to be explained by the model. Exogenous variables are originating from without or outside the model. So they're models, they're determined outside, we sort of take those things as given. And finally, the role of assumptions. Assumptions are used to simplify reality. The art in scientific thinking is deciding which assumptions to make. For example, are we talking about the long run or the short run? What sort of market are we talking about? Are we talking about perfectly competitive or oligopolies? The point is that different assumptions lead to different models, which lead to answers for different questions.